Quiz is going to be in 2 parts. So it'll be part 1 with no calculator, part 2 with a calculator. So part 1 will have questions like 1 through 10. These will all be no calculator questions. In 11 through 13, these are calculator questions. So make sure you have a calculator for Thursday, and make sure you know how to use your calculator on Thursday. We're going to do one of each of the graphing ones, so an exponential and a log, and then we'll do the rest of them too. So let's look at number 2. So first, in an exponential equation, domain is always going to be from negative infinity to positive infinity. So that's easy. That's a given. So for the horizontal asymptote, what are we looking for? What tells us?
Y-intercept?
Nope. A horizontal asymptote. So horizontal asymptote is what we're adding on the outside, what we're adding or subtracting outside. So like that big number that we'd be adding or subtracting. Am I adding or subtracting anything outside here? No. So what would our horizontal asymptote be? Y equals 0. Just taking a look at number 1 real quick. What would our horizontal asymptote be here? Y equals -1. Awesome. So horizontal asymptote moves if you have a vertical shift up or down. So if we're not adding or subtracting anything outside here, it's just 0. So then our range is also going to have 0, but let's graph it so we can tell if our range is going to be from 0 to infinity or negative infinity to 0. And then let's also find our y-intercepts and the transformations. So with our y-intercepts, how do we find the y-intercept? Awesome. Plug in 0 for x. So in my equation here, I've got 1/3 times 2/3 to the power of -2 times 0 plus 1. Santi, be super careful here when you're doing the math. You need to do your exponent first, evaluate the exponent, and then we're going to multiply by that 1/3 outside. So first thing I'm going to do is the exponent. -2 times 0 would be 0, and 0 plus 1 is 1. Bless you. So I have 2/3 to the power of 1. Next, I have to do the exponent part. So 2/3 to the power of 1 is still just 2/3. And 2/3 times 1/3. How do I multiply with fractions? Straight across. So 1 times 2 would be 2. 3 times 3 is 9. So how would I write the y-intercept? 0, 2 over 9. Awesome. Now let's talk about our transformations. So we have 1/3 that we're multiplying on the outside. What does that do to our graph? When we're multiplying, it's either a stretch or a shrink. When it's out front, what do we think? It's going to be a shrink. So we have a vertical shrink. Now when we're multiplying by a negative on the inside, now this is inside because it's in our exponent, what does that do to our graph? It's going to be a reflection on the x-axis or y-axis? The y-axis. Y-axis is on the inside. When we multiply by 2 on the inside, it's always the opposite of what we think on the inside. So is it a stretch or shrink? So this would be a horizontal, what do we think? Horizontal shrink. Because it's greater than 1, so inside, it's the opposite of what we think. So it would be a shrink when it's greater than 1. And then if we add 1 inside, which way does that move our graph? Left 1. Remember, our base is not a transformation, but our base does tell us if we have exponential growth or decay. Would this be exponential growth or decay here? Decay, because it's less than 1, so our graph would be decreasing, but that will change if we have transformations. If we have a transformation that'll flip it, that could change. So typically, when we have exponential decay, our graph would look like this, but we have a reflection on the y-axis. Reflection on the y-axis, this is our y-axis. So when we flip it along the y-axis, it's now going to be increasing. So our graph is going to be increasing like that. I'm going to draw a little bit more accurate graph down here, but now we know that because we have a reflection on the y-axis, our graph is increasing. So it flips it. So I'm going to plot my y-intercept. So I stay at 0, go up 2/9. So it'd be about there. You can plug in more points to get a more accurate graph. Just for the sake of time, I'm not going to plug in more points, but in the last class I plugged in -2 and +2, just so we can get an idea of like, we're definitely increasing there. So our graph is going to be increasing, and our horizontal asymptote goes through 0. So you can plug in more points if you want a more accurate graph, but you don't have to, as long as you know the direction. So you have to know that it starts off decreasing, but because we have that negative that gets multiplied to the x, we have a reflection on the y-axis, so it now flips to increasing. Last thing, let's find our range. What would our range be?
0 to infinity.
Awesome. It's always going to be the same number from your asymptote. It just depends if it's going up or down. So here our graph is going up to infinity, so from 0 to infinity. Next, let's look at our log function. So log function, if our base is greater than 1, our log graph is going to be increasing like that. It's going to start down low, then going high. If, let's say we had log base 1/2, anything less than 1 as our base, our graph would start up high and then go down low, like that. So here we have log base 2. 2 is greater than 1, so we know that our graph is going to be increasing like that. Now let's find, what's the easy one for a log graph? The range. Range is going to be from -infinity to +infinity always. Next, let's find our vertical asymptote. What do we do to find the vertical asymptote? Set what's in the parentheses equal to 0. So we have 2x minus 7 equals 0. So add 7, divide by 2. X equals 7 over 2. So if I were to graph that, my vertical asymptote is going to go through 7 over 2, which is going to be 3.5. 2 goes into 7 3 times. So. Now let's find our x-intercept. What do we do to find the x-intercept?
Set the y equal to 0.
Plug in 0 into the y. Perfect. So we have 0 equals log base 2 of 2x minus 7. When we solve this, we want to put it into exponential form. So what would my base be? 2. What's the exponent?
0.
2 to the power of 0 equals 2x minus 7. What's 2 to the power of 0? 1. So we have 1 equals 2x minus 7. I'm going to add 7 to move it to the other side. So 8 equals 2x. Divide by 2. What does x equal? 4. So my x-intercept, how would I write it? 4, 0. Perfect. So I'm going to go to my graph. I'm going to put a point at 4, 0. Do we have any reflections happening on our graph here? No, we're not multiplying x by a negative. We're not multiplying by a negative out front. So we know that our graph is going to keep this shape. So I'm going to start down low next to my graph, and it's going to go out to the right. So this is going to be our log graph. What's our domain going to be? 7 over 2 to infinity. So it's always going to be your vertical asymptote, just like before how we repeated the horizontal asymptote for our range. Here we repeat the vertical asymptote for our domain. So it'd be 7 over 2 comma infinity. I'm going to practice one more. So let's say we had log base 4 of negative x plus 1. So let's find our domain, range, vertical asymptote, and x-intercept. What's the easy one here? Range would be from negative infinity to positive infinity. How do we find the vertical asymptote? Set the parentheses equal to 0. So we have negative x plus 1 equals 0. I can add x to move it to the other side, so x equals 1. Let's graph that. So we're going to do the right one, draw a vertical asymptote. How do we find the x-intercept?
So y equals 0.
Plug in 0 into the y. So we have 0 equals log base 4 of negative x plus 1. So let's put it into exponential form. What's our base? 4 to the power of 0 equals negative x plus 1. 4 to the power of 0 is 1. Subtract 1 on both sides. So we get 0 equals negative x. Divide by negative 1, x equals 0. So what's our x-intercept? 0, 0. Awesome. So I'm going to put a point at 0, 0. Now, typically our log function, when our base is greater than 1, it would go out to the right like that. But here, we have a reflection. A reflection on which axis? The y-axis. So my y-axis now acts as a mirror. Instead of going out to the right, I'm now going out to the left. So that y-axis is going to act as a mirror. We just flip it along the y-axis. So our graph is going to get really close down here and then go out to the left here. Now for our domain, let's think about it. What would our domain be? Awesome. Negative infinity to 1. Perfect. It's always going to repeat the number from your vertical asymptote, but here since our graph is going out to the left, it's going out to negative infinity. Before, our graph was going out to infinity, so we had to start with the number, then go to infinity. Here, we're going to negative infinity, so you always start with a smaller number, so negative infinity to 1. Awesome. Let's do number 5. So here we're rewriting an exponential form and evaluating. So these types of questions, you cannot use a calculator. So let's put it into exponential form. What's our base? 2. What's our exponent? 2 to the power of x equals 1 over 64. So here we want to make, since x is in the exponent, we want to make our bases the same. So how could I change my fraction to be a whole number?
Make the 64 negative 1.
We're going to make it 64 to the power of negative 1. Perfect. So 1 over 64 and 64 to the power of negative 1 are the same thing. They're the same value. They just look a little different. Now, is it possible to get 64 to have the base of 2?
Yes.
2 to what power gives us 64? 2 to the 6th power. But instead of 6, what else do I have as an exponent? Negative 1. So it'd be negative 6. So we have 2 to the power of x equals 2 to the power of negative 6. Once our bases are the same, we can just cancel them out. What does x equal? Negative 6. Perfect. Any questions here? All right, number 6, we're doing the same thing. Let's start with our base. What's our base here? 81 to the power of 1/2 equals x. What is 81 to the power of 1/2? What does a fraction as an exponent do?
Square root.
It's a square root. So this is the square root of 81. The 1/2 power is the same thing as the square root. The number on the bottom would be our index, so that's what goes out front, but here the 2 as an index is implied. What's the square root of 81? 9, so 9 equals x. Any questions there? All right, 7. Bless you. Starting with our base, what's our base here? 7. What's the exponent? 7 to the power of 3 equals x. Well, here we just need to find what 7 to the power of 3 is. Let's write it out. 7 times 7 times 7. 7 times 7 would be 49. And then 49 times 7. 7 times 9 would be 63. 7 times 4 is 28 plus 6 would be 34. So 343. Yes, you may have big numbers on the quiz, but you can write it out. So just if you're multiplying to high power, just write each step out. Perfect. So let's do 8. So here we're solving using the 1-to-1 property. This is when we are trying to get the bases to be the same. Same base. In 8, we don't even have to do anything to get our bases to be the same. They're already the same, so we can just cross them off, set our exponents equal to each other. So x plus 3 equals negative 6x minus 3. From here, we just solve for x. I'm going to move my x's to one side and the constants to the other. So I'm going to add 6x, move it to the left, subtract 3, move it to the right. So we have 7x equals negative 6. Last step, divide by 7. So x equals negative 6 over 7. All right, let's do 9. So here we want to get our bases to be the same. Is it possible to get 27 to be 9 to some exponent?
Yeah.
9 to what power gives you 27?
Wait, never mind. No, that'd be 3.
But it has to be 3. We have to change both of the bases. So we can change both sides. So the common base that both of these would have would be 3. So 3 to what power gives us 9? 3 to the second power. Awesome. If I already have an exponent there, we just multiply it by the new exponent. 3 to what power gives us 27? 3 to the third power. If we already have an exponent there, we're going to multiply it by the new exponent. Since I have 2 terms in that exponent, I need to put it in parentheses. One of the most common mistakes that people will make here is that they don't put it into parentheses. When we cross these off, because we have the same base now, and we set our exponents equal to each other, we're going to end up distributing that 3. So make sure you put it in parentheses when you have 2 terms. So 2 times 2x would be 4x equals, here I need to distribute. So we've got 6x minus 12. I'm going to subtract 6x, move my x's to the left side. So we have negative 2x equals negative 12. Divide by negative 2. So x equals 6. You can always take your answer and plug it back into the exponents to see if it works out. So if I plugged in 6 into my exponents here, it's going to end up being a really big number, but you could do the math if you have time. Any questions? Let's look at 10. What do we think our common base between 1/4 and 8 would be? 2. So let's change both of these to be 2 to some power. 2 to what power would give me 1/4? Negative 2. Awesome. 2 to the power of negative 2. We still have that x there, so we're going to multiply them together. Be careful that you're not changing the value of the number. We're just changing the way that it looks. So we have 2 to the power of negative 2 is 1/4. 2 to what power gives us 8? 2 to the third power. And since I have 2 terms in the exponent already, I'm going to make sure I put it in parentheses and multiply it by my new exponent. So our bases cancel. We're going to set our exponents equal to each other. So negative 2x equals, what do I have to do on the right side? Distribute. So negative 9x plus 6. We're going to add 9x, move it to the other side. So 7x equals 6, divide by 7. X equals 6 over 7. All right, so that brings us to now the calculator part. So calculator questions are going to be our interest question, so the compounding interest. It says determine the balance for $24,500 invested at a rate of 2.7% for 4 years and compounded for 11. It says quarterly, 12 is compounded monthly, and 13 is compounded continuously. So you need to know the formula for both of these. If it's compounded and it has a specific time, so like quarterly, monthly, daily, whatever it may be, we're using the formula that goes A equals P times 1 plus R over N to the power of N times T. Make sure you know your formula. P is the starting amount. R is our rate. But what does the rate have to be? The decimal version. So the decimal version of our rate. N is the number of times compounded per year. And then T is the number of years. So we have P, R, N, and T. What's our P? 24,500. What's our R? 0.027. Awesome. For your rate, it's got to be the decimal version. So we always take the percent, move the decimal 2 places. So this would be 0.027. What's N when it's compounded quarterly? N would be 4. And time, how much time are we talking about? 4. It says 4 years. So let's plug everything in. We have A equals 24,500 times 1 plus R is 0.027 over 4 times to the power of 4 times 4. Be careful here. Make sure you put it in the calculator correctly. I always like to multiply the exponent together first. So I know this is 16. It's just going to make it easier when I do the math. Next, I need to do what happens inside the parentheses. So inside of our parentheses, we have to divide first. We've got 0.027 divided by 4 plus 1. This should give you 1.00675. Keep it in your calculator. Don't round until the very end. It'll throw off your answer. So now I'm going to do this to the power of 16. You should get 1.11364. It keeps going, but I'm going to leave it in my calculator to do the last step when I multiply by 24,500. So it should give you 27,284.267. We're talking about money here. So how many decimal places should we round to? 2 decimal places. Does 7 tell me that I round up or keep it the same? We round up. So this would be 0.27. So $27,284.27. All right, let's do 12. So 12, we're using the same formula, the same P, R, and T, but here, what would N be when we compound it monthly? 12. There's 12 months in a year. So N is 12. So let's plug everything in. We have A equals 24,500 times 1 plus 0.027 over 12 to the power of 12 times 4. So we just had to change N to be 12. Everything else stays the same. So first step I'm going to do is the exponent. 12 times 4 is 48. I just like to rewrite that so it'll make the math a little bit easier. Next, we got to put inside the parentheses, we got to do that math. So we have to divide first. 0.027 divided by 12 plus 1 should give us 1.00225. Keep it in your calculator. We're going to raise that to the power of 48. So you should get 1.11391. It keeps going, but leave it in your calculator to do the last step. Do not round until the very end. If you round in the beginning, it's going to throw off your answer. So we're going to multiply that by 24,500. You should get 27,290.858. Does the 8 tell us that we round up or keep it the same? We round up, so that would be 0.85 or 0.86. Bless you. So $27,290.86. So notice how close our answers are. They're $6 away from each other. Just be careful. If we were to round somewhere in the middle of our problem, it's going to throw off our answer. It's super important that your answers are exact to the nearest decimal. So don't round until the very end. Questions? All right. For 13, it's compounded continuously. When it's continuously, we use our different formula. It's going to be A per. A equals P times E to the power of RT. So our P, our R, and our T are the same. What do I do for E?
Just keep it as E.
Keep it as E. E is a button in your calculator. Just use the button in your calculator. You're not plugging in anything into E. So P was 24,500. R, again, is the decimal version of our percent, so 0.027, and time was 4 years. So when we plug this in, we get 24,500 times E to the power of 0.027 times 4. We have to do the exponent first. Save the multiplying for the very last step. We have to do the exponent first. So 0.027 times 4. And then we raise E to the power of that. You should get 1.11404. It keeps going, but we're going to leave it in the calculator and multiply it by 24,500 in the last step. So we should get 27,294.169. 9 tells us we round up or keep it the same? Round up, so that would be 0.17. So that would be our answer. Just as a refresher, you guys can look back on your notes to review, but some common ends that you might see. Let's say we had annually. What would N be if it was compounded annually? 1. Annually happens once a year. What about semi-annually?
Twice 2.
Would be 2 times a year. What about weekly? N is 52. Monthly's there, quarterly's there, daily? 365.